Hello everyone, welcome to the fifth lecture that is on the experiment that is open traversing using theodolite. So, what is open traversing? We have studied in theory class, right? What is traversing also we have studied. Okay, so in the open traverse, this method will be a deflection angle method where we will be finding out the deflection angles of the preceding line, succeeding line with the help of the preceding line. What is preceding line and what is succeeding line? Succeeding line is a line which is a coming forth line or a next line. Okay, preceding line means a line which is before of a point. If you say if this is a point, right? The line before this point is called preceding line. Okay, and the line, this line which is in front of that point, it's called succeeding line with respect to this circle. With respect to this point, this line is succeeding line. Okay, this line is succeeding line. So that is what traversing consists of. In the open traverse, the start point and end point are not the same. Okay, we have studied that in the open traverse, the start point and the end point are not the same, right? So before we go to the experiment, we will see the procedure of it. Then we will go for the uh, experiment, right? So here, this open traverse can be used for surveying of roads, canals, right, along the river. So railway lines, where the start point and the end point doesn't meet, right? It doesn't make a closed line, right? It is endless. Start is also not getting in contact with the end point. They are both different. So in this case, we use open traverse. In the case which what? In the tunnels, in the case of railway lines, roads, canals, rivers. So in this case, we use open traverse, right? Understanding why we use open traverse. Now what we are going to do is at the point A, right? At the point A, we are going to set up a compass, right? And you will be given an angle. You have to measure that angle with the given distance, right? If suppose this is point A, right? And at we have some point here, that is B. So what we'll do, with the help of the compass, we will bisect this point and measure an angle of it with respect to what? North. In compass, we measure the angle with respect to north. So we will measure this and we will take down this reading. If any reading x degrees, we will measure this angle and we will measure this distance also. Distance, right? Understood? So what we're going to do, we know both the points A and B. We are going to set up the compass at the point A, bisect the point B with the help of the compass and measure the angle with respect to what? A and north. From the north with respect to the from the A with respect to the north, we are going to measure the angle and the distance between the 2 points. Once we are done with that, once we are done with that, right? Then at the point B, what we are going to do is we are going to set up the theodolite. There you are going to set up the theodolite. There you're going to do all the temporary adjustments, like leveling should be done with respect to the altitude bubble. Okay, so and you should see that using the upper clamp you have to make the vernier A to be 0, right, as we have done in the previous theories or the experiments, how we have brought the uh, vernier scale to 0, right. So you have to do it that here, and then you have to bisect the point C, right, to bisect the point C. How you are going to bisect the point C? How you are going to bisect the point C? To bisect the point C, what you are going to do is you are going to first bisect the point A, right. I will show you how we are going to do that. Just understand here. You are going to bisect the point A, and then you have to turn the telescope by 180 degrees in the vertical plane, not in the horizontal plane, in the vertical plane, right. You are going to turn it opposite direction, and then you are going to take a deflection angle like this. If this is AB, your instrument is here and you are looking in this direction, right. Now look at this direction at A, then reverse it in this direction, and then make an angle to bisect point C. So this angle theta, x theta, will be your deflection angle. It is called as deflection angle. Understood what I am saying? You are at the point B, right? Bisect point A, then transit the telescope by 180 degrees, right, 180 degrees, and then move in the clockwise direction, in the where the point C has been located, right. So that will be your deflection angle. Afterwards, with the help of the deflection angle in the office work, we can calculate the interior angles also if you want. So no need of going for interior angles now. Just use deflection angle to go forward, right. Right, and you have to calculate that angle with the help of the vernier scale and the main scale. How you are going to do that? Once you transit the telescope, you have to loosen the upper clamp, right? To loosen the upper clamp, and then bisect the point C. Now change the angle phase and do once again for the point B, and carry out same throughout the length of the uh, tra open traverse. Wherever there are wherever there are connections of two lines, there you have to shift your instrument, right. So here you will get at every point you will get an deflection angle where there is a junction, right. Understanding? Now B is a junction where you got the deflection angle at the B. Same way for C, D and E you can get, as long as you go forward in the direction of the traverse, right. Well, we'll come for the real part, that is your experiment. You're going to set up the compass at A, right, and measure the angle, that is your bearing. Measure the bearing with respect to north from A to B, right. Once you bisect it, measure the distance, and you got the magnetic bearing or true bearing or bearing that you got here. So once you are done with that, you are going to set up a theodolite at station B, right. Same way at the station B you are going to set up the theodolite. Now what you are going to do is you are going to bisect the point A. You are going to bisect the point A, right, and then transit the telescope by 180 degrees. by 180 degrees, right? So what are you going to do? Right, transit the telescope, then measure the angle for the point C. Right, measure this angle, right? Now you are in this direction, you are looking in this direction. So you are going to turn the telescope towards the point C, right? And this angle you will get, suppose x degrees, right? So you are going to take down that x degrees into your, what is that angle, deflection angle at point B is x degrees, suppose. Now once you are done with that, you are going to mark the point C, right? You got a deflection angle. Then you are going to shift the theodolite to the point C. Right, we have done here. We have brought the telescope towards here. Again, you have to do all the temporary adjustments. Right, whenever you move the instrument means you are going to do the temporary adjustments. Now here, once you are at the point C, bisect the point B here again. Bisect the point B, transit the telescope, right? Transit the telescope, and then move in the anti-clockwise direction and bisect the point D. Right, now this is in a reverse direction, right? So this angle will be in the reverse direction, anti-clockwise. So this will be our y degrees, right? It will be our y degrees. You got the deflection angle. How? Once you transit the telescope, loosen the upper clamp and bisect the point D here, you will get a deflection angle, right? You have to take it down. So next will be what? You're going to shift the instrument to the point D, right? As we are done, we have brought here. We'll do all the temporary adjustments once again, and then you are going to do what? You're going to bisect the point C, right? You're going to bisect the point C, and then transit the telescope in the direction of D dash, right? This is your D dash, right? That will be your D dash. Now, then move your telescope in the clockwise direction. In the clockwise direction, can you see? There is a movement in the clockwise direction, and bisect the point E. Once you bisect the point E, you will get an deflection angle at point D, right? That you have measured through the theodolite. You have to go on doing this till you come to the last point, right? Every time you have to calculate the distance and the deflection angle of each line between the 2 points, right? That is important. You have to also measure the distance also. Don't forget that. You have to measure the distance also. Then you have to plot this and calculate the interior angle of these two lines, right? That is how you are going to do the open traversing and plotting also. For plotting you require angle as well as the distance. So for that, deflection angle and distance is enough, right? So that's for today.